Good afternoon, everyone. I want to welcome you to our fifth in a six-part training on creating R Shiny applications and dashboards. I'd like to thank the Bureau of Justice Statistics for their support, which makes this training possible. We'd like to welcome back our presenter, Dr. Robert Ashmead. Dr. Robert Ashmead is a senior statistician at the University of Chicago. I'll turn things over to you, Dr. Ashmead.
Thank you very much, and welcome back, everyone. Let me get acquainted here with the screen share, and we'll be on our way. All right. Today we have an exciting session talking about controlling data access. Specifically, we're going to be talking about some password and authentication options we can use in our dashboards, and as well as some other tools for suppression based off of different rules you may want to implement, and kind of general best practices for dealing with sensitive data in these kinds of dashboards. Last time, if you remember, we talked about hosting, so allowing other people to see our Shiny dashboards. That's kind of a key part of this authentication part of things that we're going to talk about today as well. We talked about accessibility, resources, and tips in dynamic UI elements. I did propose one kind of activity for as a challenge. In our current setup, we had in our map we had limited ourselves to analyzing information about a specific variable, but we wanted to have a more dynamic UI selection using the tools that we learned about last week. So we could first select a variable and then select a level within that variable to analyze for our map. So what I had in mind, I'm going to show you the end product first, and then we'll kind of walk through how I accomplished that. Um, So, what I was thinking about was for our map that we had created here, we'd have first choose kind of an overall variable. If we looked at, our data analysis, we had the same prosecution, offense, grouping, and degree. So you would first choose one of these, say prosecution grouping, and then what would happen is we want to drop down of the particular levels within that variable so that we can select one in order to map, because we can only really map one level at a time. So we want this to be dynamic based off of the first selection of the variable. So we get less things for prosecution degree. We have a lot of things for the offense. And yeah, so that's what we're going for. And I want to show you how I accomplished that. So this is going to be used that dynamic UI that we learned about last time. So the first thing I did was in our UI where we had kind of the drop down for selecting the initial variable, I changed that back to be like the initial list of the same outcome variables that we were using in the other tabs. And then I added an UI output it's going to be a placeholder for what we're going to implement in the server. So this will contain our dynamic selection of the different options that will be based off of a selected outcome for the map. So that's all in the UI. The next thing I did was make some adjustments to the server. Um, in I added this render UI, which is the other piece for the dynamic UI piece. Um, and then in that, I first calculate kind of the levels that we want for the selected variable. So what I'm doing is just taking our original data, I'm filtering based off the filter in the selection, and then I'm using this distinct function, which basically just gets reduces the data set to only unique rows. So it's going to calculate only a row for each of the unique levels within that variable. I'm then sorting them. And then that is the kind of the choices that I'm going to give it for my dynamic selection. So whenever this input selected outcome map changes, or these input date range map changes, these things are going to readjust so we get this dynamic list happening. The last thing I had to do, there was a couple tweaks we had to make to the map calculation, but it actually ended up needing to just simplify things. So this operation to kind of get the counts turned into just summing the variable, summing the number of records where the variable had the particular value that we selected, and then kind of computing those standardized rates as well. And then um, I made some slight changes so that we could, in our render leaflet, so it was labeled right and it was selecting the right variable as well. But otherwise, not it's a lot of little changes in different places, but it wasn't too much to change overall. Any questions on that, or did anyone else take a shot at trying that out? Okay, that code is in um, session 5, take home 1 in the examples. So if you want to take a look and try it out yourself. Okay, so let's go back to, well, before we get into the content for today, I just want to say another reminder about this final assignment. We won't have any take-home examples for today. So this is going to be kind of the final piece of the puzzle for you all to try out. Again, practicing your R Shiny skills can get a certificate from JRN. And using that other data example that we had kind of started with, but let you all work with on your own time. So there's an HTML in the GitHub with additional instructions about what to do and a reminder of how to get the data and so forth, and how to send it. Send the results to me as well. So yeah, feel free to reach out if there's questions on that. All right, so let's get into the content for today. As a reminder, we're talking about authentication methods, suppression methods, and some best practices for dealing with sensitive data for dashboard data sets. Okay, so last time we talked about authentication. Let's assume we figured out a way to host our dashboard and share it with the world, or share it within your company, or share it with a group of people. The authentication question comes into play if, we've hosted this dashboard, but we don't want everyone to be able to see it or utilize it. Maybe just a subset of people based off of whatever permissions or criteria. So how can we accomplish that? So here are a couple common use cases I've come across in my work. So you may only want a certain group of users to see or utilize the dashboard. This could be because the dashboard has sensitive or restricted data. So who you're restricting the output to is a smaller group. You could also have something that's intended to be shared in the larger public, but you're testing a version of it. And so maybe you have a development or a dev version of it someplace, and you only want a couple people to be able to look at it, access that until you're ready to make it public. So you may want to restrict access that way. Also, you could have a dashboard or a tool that is only meant to be an internal company or group resource. So you only want to have people within your group be able to access it. There's also another common use case, or a kind of slightly more complicated. You may have a lot only want to allow different users access to different data within a single dashboard or features within that dashboard. So having different users have different levels of access. An example of this from my own work, um, I've built some quality improvement dashboards, and these were working with hospitals and medical groups across the state of Ohio, and so we allowed the groups to see their own data and to see everyone else's in aggregate, but they couldn't see other specific sites. So using kind of the authentication to um, restrict or change what each user sees is a more complicated use case, but also something that can be accomplished. Okay, so the first way what we're going to talk about is options available through the hosting platform. So last time we talked about a couple different options for how to host our dashboards. One of those was Posit Connect. That was the kind of the paid service from Posit, the people who make our studio. So they specifically use a like a named user account access model for access management. So you're allowed to, when you have access to that platform, you're able to keep the content private, so just to the person that's developing with it. You're able to share it with specific individuals or groups if they have named user accounts on the server, or you're able to make the content visible to everyone with server access. Now, the key thing here is that the number of licenses to be able to like name your coworkers to be able to see um, the dashboard or not in this restricted scenario is limited and tied to the cost of the platform. So you have to individually buy these licenses for each of the named users. So this does become potentially expensive if you want to restrict your dashboards and share it with many people, because you would need to buy a license for each of them within this platform. So if you're using this, this is kind of a screenshot of how it works. Um, you can choose any of these options for your dashboard. It's just kind of click and change the options, which is nice. So you can allow anyone to use it. All users that have a named account or that specific users or group. Here, you could imagine this like admin one, publisher one, viewer one. These would be specific people with named accounts here. So that's kind of how Posit Connect works. So it works great in terms of, its ability to restrict and authenticate people, but it does scale in cost. Because of that, you need the license for each person. The other option amongst the hosting options that we talked about was through Shiny Proxy. So this was kind of the open source method. It doesn't cost anything to use. It has options tied into it to connect its authentication to a bunch of different protocols. So I'm not an expert with this like IT portion of things, but like your Active Directory, if you're in a setup with that kind of a thing, different authentic these LDAP open IDs. These are different ways of setting up that authentication for making it being able to log in and tie it to like an existing set of users. Um, they also have a what they call simple authentication, so just a plain text list of users and passwords that will work for the Shiny proxy, and you can say specifically which app or dashboard each user has access to as well. So there's a link here for more information. And in this option, it is also possible to have the user ID as an environment variable to be used within your dashboard. I haven't actually done this portion of it. So this would be like if you needed the user to have specific data privileges and that be different between different users, there's a way to have that login kind of information be transferred to your app, and you be able to use that in that app to restrict or to allow different data options there. Okay, so those are both kind of through the hosting platform options. There is a third way to do this is which is kind of like a kind of purely networking thing. You can also, if you are looking to restrict to just like within your company or your group, you can always host your dashboard on a server that is only reachable for users at your company or your group. So maybe you have an internal server that only works for if you're on the VPN, or there's different options like that that you could make that work as well. So that's just kind of a special case. What we're going to spend most of our time today on, however, is kind of building authentication into our Shiny app. So this is kind of like rather than the authentication being on top of the platform that hosts it, it's actually going to be within the Shiny app itself. So I always like to give a disclaimer here. I'm not an IT security expert for this, so if you're going to implement any of these methods within the Shiny app, I would make sure to check with your IT department and ensure that they're comfortable with these. I have personally used these in my work, so definitely people use them. But it's just to say that, I think anytime when it's in the app, you have to just be extra careful. Um, One other note here, we talked about that Posit Connect and how they have those named user licenses. Building authentication into the Shiny app that in the way that we're talking about it here, may not align in many cases with the license agreement you have to agree to for that Posit Connect service. So just beware if are considering doing this in the context where you're using that Posit Connect server. So there are kind of three R packages that I would recommend to consider for this kind of thing. The first one we're going to spend most of our time on today is called Shiny Author. The second one's called Shiny Manager, and the third one is Firebase. Um, so just we'll talk about them a little bit more. Um, if you're interested, I guess I'm not going to take the time to go through the website just based off of time, but there's a lot of good information on them there and examples as well. We're going to talk about Shiny Author the most. So this is a way to create and manage your own username and password list. So this would not be an option to kind of connect um, to, your Active Directory, that kind of thing. If you have kind of a relatively small user group and you just want to add some passwords on there, this is a good solution. So even like in the example where you just want to restrict your dashboard temporarily for access, if you have a development version and you want to wait until you roll it out to be publicly, you can just kind of stick a single username and password that you can share to the relevant folks, and they can test it out before you kind of pull that off and show it to the world. Um, just as a reminder, I think I added this to our install packages list at the front of the repo, but if you haven't done this yet, it will be good and you want to follow along, make sure to do an install that packages Shiny Author. No O in author if you're typing it out. Okay, so I'm going to show you kind of my process and how I use this. And the first step is we want to create and hash some, usernames and passwords. Um, so the first thing we're going to do, and actually I've already done for you, is create a CSV or XLS file with a column for usernames and one for passwords. So if we look at in Shiny Author, I've actually made this subfolder called Create Passwords. And I have this CSV file here called userbase, and that's the same as what's in the slide here. Um, just kind of a note in terms of my setup, as I've pushed this to the Git repo, this is normally something you would want to be very careful with access to because it would be like your literal usernames and passwords. So this is not, you would want to be careful that when you host the dashboard, this does not go with the dashboard code. This would stay separately, and you would want to kind of keep this separate from your actual dashboard code. That's the reason I have this in this subfolder. So if I was ever hosting this dashboard, I would say, take these files here that we're going to use, but don't take this user-based CSV file. Okay, so we're going to create an R script outside of the dashboard files to read in the plain text passwords and hash them or encode them, and then save the output as an RRDS or R data file. So actually, I'm going to open this up, and so we can just like look at the code and run it a little bit. So this is the same create hashed dashboards. I'm going to stop this. Okay, so what I'm doing here, just loading some libraries here. I guess I probably should have, if you need to do an install packages for this sodium package, that's what we're going to be using for the hash. You may also need to do that. Apologies for forgetting to put that in the slide. Okay, so the first thing we're going to do is read in that CSV file here, this user base. You can see I just made some very boring and not good usernames or passwords that you don't do this kind of thing in practice, right? User one, pass one, user two, pass two, user three, pass three. The next thing we're going to do is actually encrypt them or hash them. Um, Again, I'm not an expert at this, but the purposes of this is that instead of using and storing these plain text versions of our passwords, we can actually use a hash or an encrypted version of them, and so it's just less vulnerable to someone seeing that and figuring out the password. So if you actually look at this, what this is doing is taking each of the passwords and applying this function to each of them. So what we get out of that, you can see those plain text passwords get transformed into these, gobbledygook of text strings that you don't know what the original password was, but we'll have that, and the hashing protocol has a way of knowing kind of the reverse of that. The user won't have to enter these in, but this is the way it will be stored in the backend. And then what I'm doing is just saving a version of that hashed version of the file to an RDS file. And that is what we'll use when we load up the dashboard. So that is step one, kind of hashing those files and saving the output. Step two, we're going to load that hashed user passwords into global. So all this is very simple. We're just going to add a line in our global.r. We're going to load this RDS file we just created. I'm going to call it user_base to make it easy. But you can see this is just a simple load of that RDS file to load that object into global. Next step, step three. We want to adjust the UI so there is only a login page when we start up the app. So we don't want any of the features in our app to appear before the user has logged in. So how this works is that we're gonna kind of strip away the UI that we had before that was set up our different tabs and our different inputs. And instead, all we're going to have in here is some of the UI elements from Shiny Author that create the login page. And this is going to be the extent of our new UI.R. The other thing to see here is I added this ID for the overall nav bar page. We're going to need to refer to that when we add the UI elements back in dynamically um, in our next step. But you can see that this is just kind of the standard code that you'll find for Shiny Author. We're going to have a new page that's called login. And then this is just the elements for the login and the logout that it kind of has for default. And that is the extent of our UI file that we're going to use in this new setup. The other parts of it are going to be added once they log in. Okay, so what did I do with that other UI content that we had before? So I've removed that from that UI.R file, our main file. Um, and there's several ways to do this, but it starts getting a little bit ugly if I just copy and paste it into the server file. So I've actually tried to use kind of a strategy for organizing our code a little bit better. So what I did was um, I made a separate R file called UI underscore tabs um, in that same folder. And what this is just um, objects that represent our different tabs from before. So this is the exact same code we had before for our tab panels. But what I've done is I've actually made an object it's called welcome tab, and that is the tab, that welcome tab content from the UI before. Same thing for data analysis tab. It's just an object that is now the UI object, the tab panel we had before. Just copied and pasted everything in there. And then map tab, same thing, but it is now an object we can load and refer to later on. So they're kind of like functions, but they're really just these objects here. So I've made those three objects. Otherwise, this code is exactly the same as before. Okay. Our next step is we're going to actually go to global and we're going to load those objects from UI tabs using a source. And let me open that up. So all we've done here is kind of at the bottom of our global script, I'm just loading that UI tabs.r content with a source, which just basically tells R to run that file. One important uh, thing about that in our UI tabs file, we use some of these like grouping variables, map outcome objects. So it's actually pretty important that we run this code after we already define those, or else it won't know what those are. So that's purposely needs to be like the last thing in this file because it is using these previous items that we've defined. We could also do it we could define these like functions with inputs, but I think this is an easier way to do it for the moment. Next, okay, so this is where kind of most of the magic happens with our server. We're going to make updates to our server. We're going to add some credentials and login information. Um, so in our server now, the first thing we're going to put in there is this piece about credentials. So this is just pretty standard stuff from the Shiny Author package. This ID equals login. That's just kind of naming that dynamic object. User base, right? That was the name of the object which we loaded. that stores our hashed passwords. I tell it the column in that uh, data set that represents the user. I tell it the name of the column that represents the password, and then I tell it true to this sodium hash. That was the package that we used to hash the passwords, and then I give it this logout option. So this is just pretty standard. Can kind of copy and paste most of this, lining up the different variables. The other thing, um, this is all, we have this logout module. We're not really going to use that, but we'll put that in here. It's kind of the standard part of the Shiny Author. The next thing that we have in here is something we haven't used before. In Shiny, it's kind of like the reactive objects we use, but there's something called an observe event. It's a special way to perform an action in response to an event in Shiny. In this case, the action is going to be the user successfully logging in and authenticating their username and password. So how it's going to work, basically, it's going to look for a successful login, and then a bunch of things are going to happen, which are going to reveal the additional UI and server stuff. And then the other thing is if the credential information matches the user and they're authorized, we're actually just going to also remove the login tab and create our other tabs. Okay, so all that's happening in here. So we see observe event credentials, which is what we defined up here, reactive object, user authentication. So basically what this is saying, how this observe event works, is it's saying anytime this credentials user authentication changes, it's like observing any change in it, it's going to run this code. So then this next line says if the credentials user authenticated. So this is how it's telling. This is like a true false. It's saying if the user is an authenticated user, it's going to do all this stuff. And what all this stuff is the first thing we're going to do is remove the login tab, and then we're going to use these append tab arguments to add in our additional UI information. So you can see append tab navbar is just how we identified the overall navbar page that we had to add that argument into the UI. And then we have welcome tab, data analysis tab, map tab. Those are the tabs that we defined, those objects we defined that are coming from sourcing this UI tabs .r object. So we're going back to that, and then we're implementing that here. And the other thing, we're going to select it to move to this welcome tab when it creates these. All right, and that's how we get the UI to appear. The last thing we're going to do is we're going to move our server code within this if credentials user authenticated logic to make sure nothing gets created before they're actually authenticated. This is, I didn't put it in here. We can check it out. This is the old one. Check it out here. So all I did was move like the rest of the server code within this logic here for within credentials. This is actually not the most critical thing. I think it still is safe without it, but it's kind of a best thing to do it. But it's otherwise it's the same exact code for defining all the server content that we had in there. So all it is just wrapped in that if layer. Okay, so let's take a look at what this looks like. That is the last step. Let me find the run example. And just make sure we have this. Okay, so what we see here to start with, like we set up, we said we only want the login information. So we have the structure of our nav bar page UI, but otherwise that's all that is here. And just to kind of show you more directly, we've used this inspect thing a little bit to show things, but this shows an HTML document. This is before we had a bunch of stuff in here, just to kind of prove that there's nothing, it's not hiding, it's just not created in the first place. So our other content isn't even created yet. So if we log in, user one, pass one, we get our new UI tabs get created just as we had them before. Our login, log out went away. That's something you can keep if you want. There's not really an advantage in this case to logging back out. And it creates a little bit of a headaches in the logic if the user tries to log back in at that point that you have to account for. But so it's easier just to leave it out unless you need it. And we get our dashboard. Everything else is exactly the same um, and should be working. But if we go back, just to show you kind of like the difference, if I do my inspect, you see there's a lot more stuff in here now. So the actual underlying code gets created when we log in, not just is hidden. So that is the basics of using that Shiny author. Um, Other ways you could use this, we talked about you if you just wanted like very simple protection, maybe like that development site before you launch it. You could use a single username password, distribute that to the people that need to use it. You just wouldn't have as good of control if someone shared it with someone who shouldn't have it. The other thing you could do with this is you could map the usernames to access groups and subset the accessible data based on those access groups. So this is how you could accomplish that idea of, some groups or sites have access to just they can see their own data and maybe some other aggregates, but they can't see kind of each other's data. And you can get back this username as part of the credentials. And so I just wanted to show you kind of what that looks like underneath the hood. We're not going to go through an example of that because it's more complicated than we have time for today. But what you can do to kind of see that, I'm going to stop this. We haven't done any examples of this yet, but one good way to kind of if you're having trouble or you're troubleshooting, you can actually print stuff that's happening in your R code. So what I'm going to do is I'm going to print this credentials user authentication information. Um, and we'll see what that looks like kind of underneath the hood. And that'll show us some things about how we could use it. So I'm just going to save that and rerun this. So this doesn't, when we print stuff in the code, when we use a print technique like that, it doesn't show up in the actual app, but it will be printed in um, the R console here. So you can see actually what's happening. It already looks. So what I printed, it says false. So that's the authentication. That's the credentials auth. Actually, I'm going to stop this. I just want to actually print this whole credentials object as well. So that is just the user auth is just the true false, which we talked about, that you're authenticated. But if we wanted to see the full thing, okay. So you can see here, user auth false, info null. I'm not totally sure what this cookie already checked thing is, but it might save a cookie there as well. So if I put in user one, pass one, I get in, and then what happens is it has, let's see, our user one here, and then that password it has access to, and then this is our just our like our true authentication um, that we've been authenticated. So for example, this would be a way you could grab the username from that login. And if your access to the data, if you had some sort of mapping between what each user should have access to, you could use that to dynamically subset the data only to allow us like user one to get what they can. And that is Shiny Author. Any questions about that setup that we just went through? Yeah, Matt.
Yes, Robert, thank you. I wanted to ask just really quickly beyond the user role or beyond the user and password, have you worked with like user roles and really done the tiered approach of things and groups that way?
Yeah, so in that example I was talking about with the different sites and their own data and stuff. So we had like super user access where like there was an admin that could see all the
Yeah.
data, but and there's actually also in between levels where it was like there were medical sites that were nested in like practice groups. So like if you were the head of a practice group, you could see all the sites under you. But if you were at the individual site, you could only see it. So we did it pretty complicated. So there's ways to do it. It's just, you're doing that authentication and those rules yourself. So you just have to kind of make sure you're testing everything really good and everything is working in the different roles as you want it to be.
I know how complicated that can get in a lot of applications doing our application work that we do here. So are there easier tools that are available in R or that could manage that for you and provide more of the data management side of things or data governance, I guess?
I'm not. So this is kind of like the do it yourself. So there's definitely ways to manage the users and passwords, whether that's tie it into like Open Directory or this Shiny Manager I'm
Yeah.
about to show you is a little bit better, but I don't the kind of the rules about what data each group should access. I don't know that there's specifically tools out there that to make that part of it easier.
Okay.
I think that is all you're going to have to come up with the R solution yourself, which is
Okay.
I think both the blessing and the curse of R, and that you can kind of accomplish anything you want in those rules, but you may have to do a lot of it, that coding yourself.
Got it. Just curious. Thank you very much.
Yeah, absolutely. So Shiny Manager is another. Oh, Thomas Johnson, go ahead.
Yeah, so I was just wondering, is it possible to sort of track how many logins you've had? I know with shinyapps.io, you can see how many connections have been made, how many people have logged in. Is there any way to do something similar with authR?
Yes and no. There isn't anything built into it per se. But the way I have personally accomplished this in the past is to basically, anytime someone logs in or something happens with the login, to basically write to an external file that's a log. And so that you get kind of a cumulative log that's sitting behind, wherever your dashboard's hosted, that you can then look up, how many people have logged in, who logged in, you can record information that way. Um, there's probably also some like Google Analytics kind of stuff you can embed in your dashboard, but I haven't actually tried that myself.
Okay, that's really helpful. Thank you.
Yep. Okay, so let's look. Shiny Manager is a different package that does this. I'm just going to show you all like um, their default setup for this. Let's see, I got to remember what this is. So this is shiny and shiny. Okay, so that just a login there. And the thing that's built here, they have this kind of this tab that comes up with this logout. We go back to this. The Shiny manager for this role allows additional things. If we go to this, we get this administrator. Yeah, this administrator role. And this allows you to uh, kind of manually edit and add users and do some stuff with passwords here in this within this application. I think the reset password means the next time that user tries to log in, it forces them to change the password after they have logged in. But that's the kind of additional thing that this shiny. Oh, this one has some logs too that it can put in here as well. Forgot about this part. So you can see. I guess those are all me that have connected here in our session. So this Shiny Manager has some additional ways that this works. The one thing to be aware of with that is because it's interacting with the actual kind of like database that holds the usernames and passwords, the setup in like the server context is can be a little bit more complicated because it's like actively reading and writing to that your database, which holds the usernames and passwords. Whereas in the Shiny Author, that's fixed and it would only be updated like when we push an update to the app. So that's just something to be aware of. You do get some nicer options to work with. But depending on how the server's set up, it could also add a few complications as well. But so that's kind of how that works. The other pieces where, you log in and it shows you additional things, that's gonna mostly work the same way as we did the strategy we used for Shiny Author. It's just gonna have its own unique syntax for that. Firebase, I'm not going to go into today. It's just another option. It's actually runs through Google, and there is a free version of it for kind of limited authentication that I have used before. But if you use it a lot, I think there is a small price. Basically, you can allow it to like authenticate through Google or Facebook or some of these like third-party services as well, if you want to do that kind of thing, in addition to just like password, usernames and emails and passwords. But the good thing about Firebase is it actually has a mechanism to allow users to reset their passwords for the app on their own, which is nice, which that Shiny Author did not. So if you don't want to have to manage and respond to emails about people's passwords, that user management is important. Okay. Next thing we want to talk about a little bit about is suppression rules and use cases. So a common thing that happens, these kinds of dashboards or analysis, if a sample size is for an estimate or tabulation is too small, we may not want to show it in our dashboard for privacy reasons or accuracy reasons. If you're working with survey data, you often have rules about coefficients of variation for being too large for an estimate. You may have minimum sample size rules for certain variables or variables within regression models that I've seen before. There's lots of possible rules for suppression that you may want to implement. Some of them may be at a cell level, meaning like if we have a cross tabulation with a lot of cells in it, it may be I want to suppress this cell but not other cells. Or it could be, if the rule hits, we're going to suppress the entire table. So there's lots of different scenarios to build in. So how can we implement these kinds of rules in our apps? the first thing I like to recommend for this kind of thing is write your analysis code and suppression logic as a function so that you can test and make sure it works properly outside your app. So it's easier to test a lot of cases, test that things are working if you don't have to kind of manually go through and test them in the app. Um, if you are suppressing output based on some given rules, make sure that happens in the server. So there is a way in R Shiny to show or hide different UI elements based on logic. We haven't talked about it because I don't like to use it because it is A, clunky, and B, a bad approach because sophisticated users could actually go into that HTML code when I did that uh, inspect thing, and you can actually change some options in the HTML code to unhide things that way. So that stuff could still be revealed if you did it in that UI way instead of doing it to compute it in the server itself. So the example I'm going to do here, we're going to add a rule to our analysis for that our tabulations that suppresses any counts, any kind of cell values less than 10. So say like if there's few enough arrests in a particular category, we're going to suppress that number. So the first thing, according to my rules, we want to do is we're going to turn that our tab data calculation into a function itself. The way to maybe think about this, if you're not super comfortable working with functions yet, is think about inputs and outputs. This is our current tab data reactive in our server. So if we think about the inputs to this, these are basically anything that has the input in our code here. So we want to be able to manipulate the selected grouping, the date range here, the selected outcome, this option to remove the missing, this option to remove the percent column. And I think that's pretty much it. So those would be kind of our parameters, our inputs to our function. So if we write that function kind of with how those inputs that I explained, what that would look like is I'm going to say create tab data. I'm going to say it's a function of, oh, one thing I missed was the actual data itself. So I'll have arrest data, selected grouping, selected outcome, date range, remove missing, and add percent column. Remember when we give these a value, it's a default value, so it will be false unless we change this. These other ones, because they don't have a default value, you have to give it a value when you call the function. And otherwise, I just replace those input statements in the code with their function values. So basically just pulling off the input $, the whole thing. So I could test this. I'm going to copy this code really quickly. Go back and close this. So I'll just paste this here. So I'll first run our function. So these are just some 2 examples here. So arrest data, I'm going to group by sex. I'm going to group by prosecution defense, and I have a date range, remove missing, right? And I'm getting the same output that we saw on the dashboard. It's just kind of simplified in the code here. I can do the same thing with some different options just to test it out here. We haven't done any of the suppression yet, so that's not in there yet. Just turning what we had into a function so far. Okay, the next part is to implement that suppression rule. So I'm going to add a parameter to our function for using suppression. Use suppression, true or false. And then add logic at the end to filter the cases that do not meet the count criteria. So all I'm doing is taking that function, and at the very end, if my suppression criteria is if use suppression, or if use suppression is true, I'm going to filter for any to only keep any counts that are greater than or equal to 10. So we could try this out as well. So now you can see here in my example, I sorted these. So the smallest one is 10 in, this is with the suppression is false. We get the ones here. When the suppression is true, same arguments. Otherwise, the smallest one is 10, and those ones are removed. So that's turning it into a function. All right, so then we basically just have to add it back into our app and apply it. So I'm going to add the function itself to global so we can use it later on in our app. And then I'm going to, in the server, add the input portions for the app. So what I mean by that is I'm going to, in the what we had before for tab data, that reactive was this like longer portion of code right here. I can just replace that with my new function and use these input dollar signs for the different pieces. So I say selected outcome is input selected outcome, data range is input data range. It's very clear that there's like the correspondence between those two, and my code is a lot neater than it was before. So this is also a good strategy if I wasn't even doing suppression, but if you have complicated function you're applying here, kind of simplifying the code in the actual dashboard. And so I'll always set use suppression as true here, and we can take a look at this in our second example. Okay, so now in our data analysis, if so if we sort by the count, this is apparently it's not a good one. We have to go, this is the one where we get lots of small counts. So if we sort them by the smallest count here, you can see the smallest one is now 10. So we could set this to a different threshold if it was obviously important, but that's kind of the basics of how you would do that. Okay, the other thing we want to do, test out, is suppression based on the whole set of the output based on some rule. So say, for example, we want to suppress the whole table, the whole plot, if the total number of cases that we're doing our data analysis by is less than 1,000. So we have that date range in there. So say if someone selected a narrow enough date range, they're trying to say like, I know something happened on this day. Show me what happened. I want to try to figure it out. So maybe we want to limit that case. So we'll say there has to be at least 1,000 cases. So how we're going to accomplish this is we're going to take a sum of the cases in that tab data and check it before outputting the table and the plot. And there's this strategy we can use where instead of outputting the actual table or plot object, we're going to output null. And that's going to not show our table and our plot. So we're going to do this for both our table and our plot. So what that looks like is I'm just adding this last piece here. So I'm defining P, that's our plotly object. So I'm saying if the sum of the data in our data table is greater than 1,000, we'll output P, else we'll output null. And then we'll return either that P or that null. And I'm going to do the same thing for my table. And then I'm going to also add a text message for the suppression. I'm going to skip over that part because we're short on time. But let's take a look at what that looks like. All right, so now say it shows it normally. We have a big enough range here, but if I was to go to 2014. So just like a 2-day window here, and I tried to do it. It's outputting null now instead of the plot and the table. And I actually added this message as well, and it doesn't show it here, and it's not available. So that's a good option if you need to basically not show the output based off of that rule. Just quickly, the last piece here I was going to talk about was best practices in general when we have sensitive data underlying. Kind of big picture, users cannot see the raw data that's behind our dashboard unless we kind of let them and show it to them in our output. Still, it's a good idea to be cautious about what's in those data sets used in the dashboard when the data is sensitive. What I always like to do is first pre-process to a dashboard data set. I haven't done that in these examples here, just out of ease of use. But what I like to do is create what I'll call a dashboard data set outside of the actual Shiny code, kind of similar as we were making those passwords, rather than kind of maybe doing some manipulation in that global.r file. And in that dashboard data set, I'll make it as restricted as possible in the sense that if there are variables I don't need, I'm not using in my dashboard, we'll throw them out, we'll remove them. If I have identifiers that I'm not using, person level identifiers, let's throw them out just in case to have like the most limited data set that we have when we're putting it on the server. The other thing that's a good idea, if you have to use IDs, sometimes you need to join or group by IDs in your data to do your analysis. What you can actually do is use a strategy to kind of like use some fake IDs. So rather than, grouping or joining by social security number or something really worrisome in your actual dashboard, you can kind of make a substitution for a placeholder ID when you're making that dashboard data set and use that in the dashboard data instead of the sensitive ID. Now, this doesn't apply if you need to actually show those IDs as the output in your data set, but otherwise is a good strategy. Obviously keep trying to keep those the crosswalk between those two safe as well. The last thing is just like really rigorously test your dashboard when you have that sensitive data. Make sure the users aren't able to see something they're not supposed to see. There's some error that happens that mistakenly allows them to see some sort of output. So kind of trying to go through lots of different options for the different selections to make sure they're not seeing anything they shouldn't. Okay, so summary, we talked about authentication options, both within the hosting platform and built directly into our Shiny app. We talked about implementing suppression rules and a few best practices for creating dashboard data sets with sensitive data today. Next session is our last session next week, Friday. We're going to be talking, we're kind of go beyond our Shiny a little bit. We're going to talk about some alternative reporting options, R Markdown and Quarto. We're going to focus on R Markdown, but I'll include some examples for Quarto too, if you've heard of that. There is a specific download for Quarto that you'll need to run some of the examples. So just a heads up on that if you want to follow along. And then remember the final assignment if you want to get to try that out. And I'll take a look at your results and you can get a certificate for completion. That is all I have for today. As usual, lots of too much content for the time, so I'll quit there and see if there are any questions from folks. It may be. I've mostly run it outside in a command line, and sometimes it gets a little bit strange within the RStudio by it. Sorry, this is responding to Jim's question about Quarto integrated into RStudio. Any other questions today? Okay. If you have any questions that come up about authentication, feel free, or suppression or any of these rules, feel free to reach out. I think this is starting to get into some complex territory for this kind of thing, but there are lots of things you can do with R and R Shiny to do that kind of thing. So there's exciting possibilities out there. So thank you. Jason, over to you.
Yeah, thank you, Robert. We appreciate it. Another great session. So when we close this, there's going to be a brief survey. If you could take that, we'd appreciate it. Everybody have a great weekend.
Thanks all. Bye.